So I'm indeed going to be speaking about building what I believe are fairly small container images of Nix. But I want to have a bit of a history of why I wanted to do this at a cloud-native track. I have given a version or variations of this talk at multiple Nix events or Nix-focused events already, and they all go pretty well, actually. I always get very good feedback. Everybody always agrees with me, and it's always amazing. And that's when I realized, like, oh, I might be talking to an echo chamber, right? People might be agreeing with me because they have already been sold the Kool-Aid. So, who am I? I'm Bryan. I'm a software engineer at Flux. Flux uses Nix under the hood, so that's fairly cool. You can find me at all of those things. Feel free to reach out to me. Flux also has a booth over in the exhibit hall. Feel free to come drop by, say hello. Nix and the NixOS community also has a stand over there. Please do go there. So, what is this Nix thing, right? Because first question may be, who here knows Nix? Drop your hand if you mean that you've heard of it, right? Or if you're actually using it, I guess. Are you using it, is what I'm asking. Okay, that's quite a amount of people. So keep it raised for a second. So the people that don't use Nix, if you're confused, look around, right? Ask the questions to them. Cool. So I always like to talk about Nix as this very overloaded term, right? It's a lot of different things. It's a package manager, it's a language, it's an operating system based on Linux, it's a whole new idea of doing software management and software deployment, and it's a whole new way of how software is built. There's a binary cache that's like the largest one in the world right now. It's like 120,000 plus packages or something crazy like that. It's a whole lot of different things. And then there's all these community projects that have Nix in their name somehow. So if you ask me what's Nix, my answer is yes. And it's pretty notorious for its steep learning curve. I do not believe there is a steep learning curve at all. I believe the steep learning curve is an illusion because you can approach Nix from so many different angles, right? You can use it as an operating system on your computer, on your servers and supercomputers. You can use it as just a package manager on your Red Hat Enterprise Linux, right? That's possible. You can just use the language, although I've not yet seen anybody do that successfully yet. But you can just use the language, for example, as a configuration language, right? To generate templates. That's possible. But for the sake of this talk, I'm going to be limiting myself to look at Nix as a way to generate Docker images, okay? So yes, I know that there's a bazillion things that are very cool about Nix, but for this talk, I'm limiting myself to just outputting Docker images, to keep it simple. I'm going to be using something that's called Docker Tools. That's a library that resides inside of Nix packages. So if you're using Nix and you're pulling Nix packages from the internet, you already have access to this. It's pretty awesome. But first, I want to show you some Docker files, right? Because this whole talk is about generating small images, specifically, or pretty small images. And I wanted something to compare against, right? Something to compare against that Upstream is already doing. So I have this fairly simplistic Docker file, at least I believe it's fairly simplistic. It's using Alpine. It's installing some package. I didn't know Causa was in a different repository on Alpine, which is a surprise to me. It doesn't have the hello binary, which was also surprising to me, so I just echo hello world, and then I create a small script that does hello pipe Causa. And if all goes well, you build this thing, you run it, you get a cow that says hello. Great, very interesting demo, I know, sue me. The thing it's about is the size, right? This image came out to be, at least as building of today, it might change in the future, it might have been different in the past, I do not know. As of building this today, it was 38 megabytes, or about 38 megabytes. Cool, not bad. But what if I use a different distro as a base image, right? That could influence a lot. Alpine's based on Muscle. If I use a different image, might be based on libc, might not be based on OS at all if you have a distroless container. So let's see, right? All of these comments, the slides are online. I invite you to read them. This was me questioning some of the decisions, let me put it that way. Even in a very small Docker file, I had a lot of questions about it. But okay, whatever, let's get rid of the comments. This is the essence of this Docker file. So we're running Debian stable. We're doing an apt-get update, apt-get install. This time we have hello and Causa in the default repository. Great, I don't have to do extra work. I'm also creating my small applet again, and I'm running that whenever I run the container. Just as proof, it does actually run. It's 200 megabytes. Just to refresh your memory, the Alpine one was 38 megabytes. That's a whole lot more, just by changing the distro, basically, right? I mean, Kause and Hello on most distros are not that dissimilar, but still we end up with a difference of more than 100 megabytes. Cool, Docker is great. I love Docker. I love it as a runtime. I love it as an ID. But honestly, I really, really like Nix, right? So let's go ahead and see the Nix equivalent now. Don't be scared. We're going to go through this. This is Nix code, right? It looks like JSON, or at least I hope that if you squint your eyes very hard that you see JSON in this. But it's really not that difficult to read. You have to take it slowly. So I'll guide you through it once. So at the top, we have this thing called an attribute set, right? And the attribute set you can identify by the squiggly braces. So on the left and on the very right, we have squiggly braces, yes? Everything inside of that attribute set is called an attribute. So we have an attribute called Docker tools, we have one named hello, Kause, write text file, lib, and shell. We'll see in a moment where those are coming from, right? But these are just, well, attributes of this attribute set. The little colon at the very end, at the very right, is telling me that the left-hand side, so the attribute set, is an input to a function that returns the bottom part. That's what the semicolon means, or the colon rather means, right? So I have a function that takes one input, being the attribute set. I very often read this as a function that takes multiple inputs, because that's what the attribute's really taking one input, but implementation details. And then the bottom side is what the function will actually return, what it will actually run, right? In this case, it will return the result of another function, that being Docker tools.build layered image, right? So I showed you a little bit before that we are importing something called Nix packages that has a library function called Docker tools, and a function that's inside of Docker tools is build layered image. It does exactly what it says on the tin. It builds a layered image. There's also a build image function that builds, well, a container with one layer in there. So that's why I'm using this one, build layered image. We like layer caching, blah, blah, blah. Cool. This function, build layered image, takes as argument another attribute set. We can see that by the squiggly brackets. We give this container a name. So instead of naming the container at build time, which I find very weird always, you write the Docker file, but you never give it a name. You give it a name when you build it. With Nix and Nix packages and Docker tools, we give it a name when, at declaration time instead of at build time. Then we also have the same config options that Docker has. I am vague for a minute on what the actual document is called again, but the OCI has a document somewhere of all the different config options that a container should accept, right? And Docker adheres to them, Containerd adheres to them, and the thing over here, build layered image coming from Docker tools, also adheres to them. So config.cmd, those familiar with Docker files, no CMD, the no entry point, you have your user. We'll have a bit more of a complicated example a bit later where you'll see more of those options, or more of those config options declared. Cool, now I have this weird let thing, right? Let, and ignore everything that's inside the let and start reading it in again, right? So let, some garbage, and then in, and then we have this, I hope at least that it seems familiar, the square brackets, and then we're referencing the app. I'll come back to what the reference is in a minute. But so if you just in your mind delete everything within the let and within the in, you will see that this is the same thing that we did in the Docker file. If I go back to that real quick, there we go. It's like the entry point. I didn't use the CMD there. I don't know why. It was late when I created these slides. I'm sorry. So the entry point also has the square brackets and then the arguments that the entry point accepts, right? Nix has the same thing. There we go. Cool. Now, this let binding, right? All that's doing is giving me an opportunity to declare variables, basically, right? In this case, I'm declaring a variable app. It's calling a function called write text file that, guess what it accepts? An attribute set, I heard it in the crowd, thank you. And that attribute set accepts as parameters a name if the thing should be executable or not, and then the actual content of the text file that will be written to disk, right? So in this case, again, I'm doing the shebang to bin sh, shell over there. We're going to see why I put it like this in a bit. And then I'm calling a library function from Nix packages again called lib.getexe hello. So what this is doing is lib.getexe is a function that doesn't take an attribute set this time. It takes what we call a derivation or an installable. For the sake of this talk, it's software. So lib.getexe accepts software as an argument, and it will return you the full path to the executable of that program. Because the hello package, for example, in Nix packages, could include more than just a binary, right? It could include the documentation of the package. It could include things that are needed during build time. It could include more than just a binary. So in this case, I'm just interested in the executable, so I ask Nix to do that. We pipe the result of hello into lib.getexe cause, exact the same thing as before. Cool. Now you're probably wondering what these $ squiggly lines are, right? These are references to other things somewhere in this Nix file. In this case, shell is referencing to the input of the function, right? Lib.getexe, well, that's coming from lib. That's also coming as an input. Hello is also coming in as an input. Again, lib.getexe and cause, both are coming from the input. And then app itself is referencing to the app in that let binding. So far, so good? Yes? Who did I lose? Yes? Okay, cool. The question was, it's a layered image, fair point. What's my base image? Nothing. The best way I can describe this is doing it from scratch. I'll get back into that a little bit later in the talk when I'm talking about the advantages, right? If you want to know right now, it's basically doing it from scratch. The layers are going to be determined by the software that I put into this container. And the software that I'm putting into this container is shell, hello, cause, and then all of its dependencies as well. Nix is able to just figure this out. Whereas with Docker, you would probably do a from Alpine, and then you have to install all of the software that you need, and that would then create all of your different layers, right? Nix packages as Docker tools will figure this out for you. The order of the layers that this generates is also deterministic. So the software that I put in, or depending what software I put in, it's always going to generate the same order of layers. So your layer caching should be fairly good if you use this approach. Does that answer your question? No? We're doing it from scratch and we're putting software in there. Okay, cool. Now we have the second file. We could have done it in the same file. I did it in the second file to fit it on a slide. You can imagine if I tried to fit this on a slide, it wouldn't have fit. Over here, we have a let binding again. We are declaring what packages is, right? So in this case, I'm importing Nix packages. I could have been more verbose, and I could have pinned a very specific commit hash from Nix packages itself. In this case, I was like, no, whatever my system has is good. That's basically what this is saying. So cool. Import Nix packages, call that thing packages, and then from packages, call the function call packages. This is a Nix packages implementation detail again, but it's just a very nice helper function that I will be using in the talk later as well, more extensively. Call packages accepts hello container.nix, so the path of the Nix file that I basically want to pull in there. It then accepts another attribute set, and that attribute set, I hope you can see hello, cause, and shell that I also pass as inputs in the other file, right? Yes? Okay, can you speak up a little bit? Sorry. Right text was not there. That's a very good comment. So in this function over here, I am not declaring, or rather, when I do call package, right, there's a few things missing. And those things would be Docker tools, write text file, and lib, I believe. That's correct. What call package does is Nix packages knows of some of these defaults. So for example, write text file, there's a top level declaration of all of the different things that Nix packages has. And call package is able to figure out like, cool, if you don't pass me write text file, you probably just mean the thing that has the same name. So it's filling all of those things in for me. In this case, I am overriding hello and cause and shell. I could have left away hello and cause for this example, and it would have still worked, and it would have produced the same image at the end. Shell, I don't believe I could have left away because that's just not a default thing in Nix packages, or that's not a default package in there. So call packages doing some magic to fill that information in for me. That's a very good remark. Cool, ugly syntax, I know. It'll grow on you, trust me. It's JSON-like functions, but it can get very convoluted. It takes a while to get used to, but once you get used to it, it's amazing what it can do. Just to prove that it works, I built this default.nix, the default.nix being this file, right? So I build it, and then I docker load I for the file. Nix build by default produces the folder or file result. Cool. So I load that into Docker. I do a Docker run. My cow is saying hello again. Life is good. I'm happy. It's 160 megabytes. I promised small images. I am not delivering on the small images promise, but I tried. No, we're actually going to go a bit deeper. And this is why I did it this way, to split it up in 2 files. I'm still using call package, so this is the same default.nix from last time, but I'm just editing it, right? I still use call package, and I'm still using the exact same hello-container.nix that I declared with the whole function inputs and attribute sets and build layer terms. It's the exact same file. Nothing has changed. The only thing that has changed is that right now I'm going ahead and call it packages.packagesmuscle.hello. What this is doing, the previous example, this one, this was using libc, GNU libc under root. The default build environment for Nix packages is kind of tailored to GNU libc with configure, make, and GCC. That's the default environment inside of Nix packages, but it's fairly easy to override this. So over here, I'm going packages.packagesmuscle.hello.cowsay.busybox. So I'm using a hello binary that's compiled with muscle. I'm using a cowsay binary that's compiled with muscle as well, although cowsay is Perl. It will use then muscle to compile Perl and all of those things. And then busybox instead of bash. Okay? Just to prove again, it works. And if I could get a drum roll, it's still big. Right? I failed my talk. I am very sorry to disappoint. I should have consulted my colleague Tom, because literally I was in the exhibit hall 18 minutes ago, right before this talk started. And Tom comes up to me, I'm like, Tom, I cannot get this image any smaller. And he's like, oh, let me show you this one command that'll tell you exactly what's wrong. I'm like, cool. I should have had this, I needed this information yesterday. I will show you what Tom showed me, and you're going to see another cool thing about Nix. I died. Let's look at a more, what I like to call realistic, simple example, right? Why realistic? I don't know of any startup or enterprise company that is selling a hello piped into cowsay as a product. I like cowsay, I like hello, but nobody's paying money for me to run those scripts 10,000 times a day. And simple because instead of having 2 programs and having bash and needing an entire environment or core util, so to speak, I'm just going to focus on one binary, okay? Cool. What I'm going to be comparing against over here is the upstream memcached based on Alpine. Yes, that comes out to be 11 megabytes as of today running this on this laptop. Okay? This is the Nix file. It's big. If you go look at the upstream Docker file for this one, it's a 2-stage build. The first one is based on Debian. It does a whole bunch of things for the configure script to run correctly. It then does a whole bunch of things to compile it correctly. It then does some cleanup. It does some optimizations. And then eventually it does a from scratch, I believe, or from Alpine, sorry. It does a from Alpine to pull memcached in, right, and run memcached that way. That turns out to be 11 megabytes. It's fairly large. It's not a very complex Docker file, but it's fairly large. Larger than this, at least. It wouldn't fit on this slide. That's why I left it out. So, again, what am I doing over here? We have our function again. This time, I'm only pulling in 3 things. I'm pulling in Docker toolslib and memcached, right? I'm calling the exact same function as I did before with Docker tools.build layered image, and I'm giving it a name again. But the interesting part about this, well, I'm going to make the middle part a bit shorter, just to make it a bit bigger, so hopefully it's a bit more readable. The interesting part about this Nix file are these lines, really. Right? We saw that we can have the config.cmd, so I'm starting at the bottom, but we can also set the user this way, right? Through Nix. We can config.user and then set the user. We can do config.exposed ports and then set the ports that we'd like to expose. We can also set the UID, the GND, and the user details, basically. And then if you go back to this fake NSS override thing, this is basically generating /etc/passwd and shadow. That's what that's generating, and that's the content of those. Those who know the syntax of it should look fairly familiar. Okay? So this is giving me a Docker image at the end that actually adheres to the best practices, right? First of all, I'm not running it as the root user, right? I'm declaring which port I should be exposing, and in a very weird, wacky, and taking a lot of indirections way, I'm doing a multi-stage build. Okay? Same thing as before. My default.nix now looks like this, where I do the call package, I give in the memcached container.nix, and then I'm setting memcached to use the muscle one. Could have used the libc one, but I want to use the muscle one because I hope that this will result in a smaller image. It's 5.4 megabytes when I built it, and it runs, trust me, I tested it. As far as I'm aware, 5.4 megabytes is indeed smaller than 11 megabytes. Does everybody in the room agree? I see a lot of nodding. Cool. I won. It doesn't run cow, say no. That's true. I'm going to stay on this slide for a little. What have I proven with this, right? Not a lot. I can generate small images with Nix. Cool. What I hope you can see in this slide is that if I had a memcached that my company had forked, right, and they were maintaining themselves, with Nix, this would have been, okay, sure, switch out the last part on the right, and you're using that memcached. There's very fancy ways to overwrite inputs of this memcached. So I'm not 100% sure of what the actual dependencies are, build-time dependencies that is, of memcached. But let's say it depended on OpenSSL, right? And for some reason, there's a security vulnerability in OpenSSL, as there sometimes tends to be, and I have to use the absolute latest one that I can get. I can overwrite that OpenSSL. That's a very cool feature. If I now wanted to have this image, this memcached container, in just multiple different variations, let's say that you have a container that you have per customer, and there's just this very small thing that changes per customer, right? In the Docker world, well, there's ways to pass the arguments in, but everywhere that I've worked so far, what they do, they just copy-paste the Docker file, they edit what they need, and they build it that way in CI. That's what I've seen more often than not. People don't bother with learning Docker file properly, let alone adhere to the best practices. With Nix, this would have been a second function call of the exact same file, thus guaranteeing that I'm building a very similar image in the end, right? This Nix packages thing is guaranteeing me that if I run this right now, and I wait 5 years, and for some reason I have to build this image again, it's going to end up exactly the same image. There's no question about it. Caveat, yeah? Caveat, not in this form. There's a different form of importing Nix packages that will guarantee that. This is now dependent on my system. However, I do not update my system for 5 years. There we go. Yeah, there's a different way to import it, but for consistency's sake, for conciseness sake, rather. Cool. That's what I can do with Nix today, right? I have what I find very nice language, because it's a fully fledged programming language. I can do a whole lot of things in there. I have a fully fledged programming language that I can use to build container images, and they don't even have to just be container images. I could use the exact same source code, right? And instead of doing docker tools.build layered image, I can output a VM. I can just output a binary. Heck, I can, if I really so desired, output a Helm chart that also referenced the Docker files, or the Docker images that were also built through Nix. And I can interconnect them all, so that when I do Nix build, sure, the build is probably going to take an hour, because it's going to have to do a whole lot of work, But I press build, I go grab my coffee, and when I come back, hopefully it succeeded, and if it succeeded, cool. Now I have a Helm chart that I apply, it just works. But what does the future hold, right? I believe that Nix is capable of way, way, way more in the cloud native space. First thing is Nix Snapshotter. It's a tool that brings native understanding of the Nix store model to Containerd. What does that mean? Imagine that your manifests, right, the thing that you actually push into your container registry, aren't megabytes in size, aren't kilobytes in size, or like hundreds of kilobytes in size, but are like 1, maybe 2 kilobytes. Imagine that. They're very, very small. For your registry, they're very small. Eventually, when you end up in runtime, there's going to be there's some things that have to be done to write it to disk, and the actual container size will be larger when it's run, right? But it will only have you kind of delayed when the pulling has to happen. You're putting all the information into just the manifest. You're not actually providing the blobs. You push that to your registry. The next time that you run it, Containerd is able to realize the Nix store paths on disk and bind mount those store paths inside of the container. A really cool thing, something I find really cool about this is that your layer ordering no longer matters then. Because you're just bind mounting store paths that are always unique into the container. So which order you bind mount them in, I don't care. Where layer ordering in some cases is very important, with Nix Snapshotter it just doesn't matter at all. Another thing that I'm looking forward to is KubeNix. So I have a personal vendetta with YAML files. There's a bazillion different ways to get around this. This is just an extra one. Instead of using YAML or another preprocessor, you can now use Nix to generate those YAML files for you. It can also help you with setting up clusters. There's a bunch of different things that this can do. It's just a very cool project, in my opinion. Then there's the place that I work at, Flux, right? It's one of the reasons why I'm giving this talk. The containers that we produce are about 300 megabytes in size. If you're doing anything useful, they're almost half a gig in size. I've seen them balloon up to 16 gigabytes in size. So again, this was for me a reason to go research, like, hey, are there ways that I can bring those sizes down? But we can take your environments, generate container images out of them, and you can do whatever you want with them after that. Another thing that I believe is that Nix should be a part of the CNCF. It can be located in many different places on this landscape. It can be your build thing. It can be used to set up your Kubernetes clusters. It can do a whole bunch of different things. It would be really nice if Nix would move a little bit into this place as well. Some downsides. I'll admit, it's very easy to create accidental dependencies. I'll show that in a little bit. You have to learn an ugly language, but you learn to love it, right? If you have ugly children, you still love them. If you're doing what I'm doing, you're moving a very fast-moving target called Nix packages. I'll show you, just because I can, how fast I mean. Oh, did not want to do that. Does that say mirror? Thank you. Let me exit out of this real quick. Where's Chrome gone to? It has disappeared. Great. There we go. If we go look, Nix has Nix packages. What I mean by very fast moving, it's 746,000 commit messages at this moment. The last one happened 30 minutes ago, and there's a commit, every half an hour it seems like. It's a very, very active community. Let me put it this way. It's a very large thing because of it, but it's just a very active community. So if you're not careful about pinning Nix packages, you are going to be doing a whole lot of rebuilding. Where's my slides? There they are. Cool. I don't have my speaker notes, so I'll just do this. Easy enough. Oh yeah, and you'll have to adopt a whole new way of thinking about how software is built and how it's deployed. What I mean by that is Nix works on what we call the store model. Every single piece of software that's on your system that's built with Nix at least will go straight into that store. But Bryan, what about my /bin/bash, right? Or my /user/bin/bash? Well, those could just be symlinks. Whereas the FHS these days, more often than not, like for example, /user/bin is a symlink to /bin or vice versa. It's very weird. Nix just threw all of that out of the window and said, nope, we're throwing everything under /nix/store, and we're creating symlinks there where necessary. But it's a very different way of thinking about how software is built and how it's deployed. So that's, in my opinion, a downside, because that only makes the learning curve steeper. But, in my opinion, the advantages outweigh the downsides. First of all, if you work with Nix, you are joining a very awesome community that is willing to teach you and talk about this for literal hours. Every time that I went to a Nix-based conference, the nights were not very early. They always extended into the night, and we were only talking about Nix. It was truly amazing. You are joining the largest package set in the world. Sure, Nix packages is very fast moving, but it also is the biggest one of its kind, right? That means that if you need a package, there's a very high likelihood that it's in Nix packages. Nix can be installed on your system that you're using right now, and on your colleague's system. And heck, why not your whole infrastructure? And why not pin Nix packages so your whole infrastructure uses that Nix packages, so that your developers are using the same dependencies as your infrastructure, and that if you have to onboard somebody, you are sure that their developer environments will work. You are sure that if they run kubectl apply, that it's not using a kubectl that's incompatible with the current kube API that you're using in production, because everything is linked together. It's a very awesome feat, in my opinion. And then I forgot all of the other things that I wanted to say, so I'll have to look at them. I'm sorry. Integrations with the cloud ecosystem are popping up left and right. Snapshotter, the Nix Snapshotter, the Kube Nix One, whole ways of setting up Kubernetes with Nix OS. Again, I believe we should be part of the CNCF. I believe that we should try and get in there because we are doing a lot of cloud native things. You will benefit from the work that has gone into and will go into optimizing Nix packages. I was able to do packages.muscle.hello. I'm not sure if anyone has ever tried to compile something from source, once with libc and a second time with muscle. Raise your hands if you did. There's one hand. Nobody does this, and it's a very complicated thing if you have never done it before. There's very smart people in the world that do this, but with a Docker file, that information tends to get lost. With Nix, however, I can just go look at the source code inside of Nix packages and see what happened. It's a monorepository, literally everything is in there. Once your package is packaged inside of Nix, or inside of Nix, it doesn't even have to necessarily live inside of Nix packages. It has, you just have to package it with Nix. Doesn't matter anymore what you output. A Docker file, sure. A Docker container, sure. You want an OCI compatible container that just ditches everything that Docker ever said, sure, why not? You want a VM, sure. You want a VM with a different Linux or a very specific Linux, sure. You just want the binary, sure, why not? You want the binary and all of its dependencies, yeah, sure, we can do that. You package it once and output many times. It's a truly fascinating thing once you did it for the first time. And that's the advantages I think that I wanted to say. Yes, cool. There are some resources that I invite you to check out. The slides, by the way, are also on the website, the talk. All of the images should have a link attached to them, so you just click the image and it'll open up in your browser. The first resource, of course, is all the different Nix packages, Nix OS documentation that exists in the world. The wiki.nixos.org, I find a very amazing resource. Nix.dev if you want to learn the language. So there's Nix.dev and there's a whole language tutorial written by one of my past colleagues. It's really exhaustive, it's very nice. And then there's also just the website in general. If you go to, there's a little tab, Learn, where you can learn about Nix specifically, Nix packages specifically, or Nix OS, if you're into that. So this is for learning Nix. There's also this blog post by Mitchell Hashimoto that talks about using Nix as a base image to build software, right, to then eventually put it in it from scratch. So if for some reason you are not capable of installing Nix natively onto your system or onto your infrastructure, you can still head into this route, where you still write a Docker file, but you're still leveraging all of Nix's benefits inside of that Docker container. This means that I, for example, believe that the Go way of building containers is amazing. You do a from Go as a build container, you try and output a static binary, you do a from scratch, you copy that static binary and the things that are necessary, and that's it. That tends to produce very small images. Now, imagine if this wasn't only the case for the Go ecosystem, but for your NPM ecosystem as well, for your Java ecosystem, for your C ecosystem, for your Bash ecosystem. Nix packages can truly do all of that. I just showed you the build layered image to build Docker containers, or OCI containers rather, I should say. But it's not limited to that. It can also build packages for Python, for example. And there's a very nice function that helps you with the most common things. The defaulting MK derivation, what we call, is set up for building C, for example. There's one for NPM. The NPM ecosystem is also quite exhaustive inside of Nix packages. So there's already quite a lot of language ecosystems that you can just use and benefit from today. Then there's also this blog post that I encountered randomly when I was creating this talk. And this talks about how to debug containers that are distroless, right? That don't from Alpine or from Debian. To come back to the question of like, what is this base image coming from? There is no base image in this regard. You can use that image as a base image afterwards, but there's nothing that we're starting from. There's a way to have it start from something, just not something that I showed. But of course, if you have a distroless image that doesn't have a shell, it's quite difficult to debug. This slide saved my ass many times during the creation of this talk. It's like 5 different ways to do it, but one of them is really cool. And that was basically the theory side of things. There was one more thing that I wanted to show you. And this is probably not readable at all from the back, right? Yeah, we're going to make this way bigger. Is that better? Yes, no? Cool. So, you might remember during my talk, this one container was larger than I expected, the Cause one, right? And if I were to dive into that one just real quick, that would be this one, yes. So give that a second. That should be in my system. There we go, cool. And I just scroll in all the way, because I don't really care about the layers. What I do care about is, first thing you might notice is that the only thing in this container really, this word, there we go, is the Nix store. That's literally the only thing that's in this container in its file system. I don't need anything else. The command of this container is referencing a store path in that store directly. So you don't need to put it in /bin or something like that. We just know the store path. Anyone know a way to hide the left pane? Otherwise, I'll have to make it a bit smaller again. And you'll just have to trust me on what I'm saying. This is the container that was built from muscle. Oh, wow, of course you do that. Okay, I'm just going to select it so you know it's there. Right. But for some reason, it keeps shifting everything to the right. Didn't do this before. Really? Okay, this will have to do. This is the image that was built from Muscle. So the thing on the right that I've selected right now is the store path to the Muscle static libraries, right? And if you go, Bash is still in there. Why is Bash still in there? The first time that I saw this, this makes no sense to me. I specifically asked it to use Muscle. I am not expecting Bash to make its way into this final image. There's also glibc in there, which I'm using Muscle. Why is glibc making its way into this container again? Those were the two that just dumbfounded me, so to speak, and that's also, if I managed to get rid of them, I would have been smaller than the upstream image. So, my good colleague Tom, a few minutes ago, taught me, and I'm going to teach you as well, this command. So this is a command that says nix y depends. Should have known about this command. It does again what it says on the tin, right? And in this case, I'm asking it like, hey, so remember when I do nix build with the Docker tools thing, it generates this result file by default. So I'm asking it, why does this result file depend on, and then the store path to bash? The one that you just saw in Dive, or at least I saw it in Dive, you probably didn't, but you know what I mean. And then I'm asking it to give me all of the reasons and be very precise about it. So if I run this, what you're going to see is, over here we see Causa. Cool. And over here we see that the CMD part of the declaration depended on Causa. This makes perfect sense to me. But then bash is over here as well. Now where's bash coming from? It's coming from Causa. So Causa is the reason that bash sneaked its way into this container. Cool. Why is that? Well, is this the one? Yep. That's because if we go look at, again, this is just a nix file. This is the actual nix derivation, what we call it, that builds Causa. And if we go look at it, right over here, we have this thing called a post install. So we have built the software successfully, and now we're going to do some extra things to it. And in this case, we are going to wrap the program. Guess what wrap program does? It pulls in bash to create a bash script of our Causa to have a suffix for the cow path in there that references to something. So why did it pull in bash? Basically this piece over here. Is this wrong? No, I was just stupid and I forgot to check the source code of the package that I was pulling in. That was my problem. I could have also known about this command that would have told me literally why it was pulling it in. Then Tom also told me about this cool PR that just got merged. So one thing right now is if you generate the Docker container, or the container in general, sorry, with the Docker tools, stream layered image or build layered image, the order of those layers you can't really control. There's an algorithm in there that does it by default. This pull request gives you the power to mess with that ordering, to merge certain layers together that contain certain programs, for example, or to just like, I don't know why you want to do this, but like reverse the order of the layers as a possibility. There's some examples down here if you scroll down. That was a fairly good one. Is it this one? Yep. So for example, this would be a rule of how to order these things. In this case, it gets every subcomponent of Python 3, puts that in the same thing, and then for all rest, all of the other layers, it pipes it into a popularity contest and it limits it to 100 layers. Popularity contest is the default thing that's used right now to this day. We can also control the layer limits right now today, where you can say like, hey, I just want one layer, I want 10. There's multiple reasons why you want to be able to do that. And I'm honestly open for questions right now. Thank you.
Hi. So you did build an image, you measured the size, then you did use different packages, and then you did this discovery about how Causa is pulling the bash. So this is a lot of knowledge and understanding of the system. Of course, if you just, okay, I just want to do that for my software, I might not know this or might not be able to figure out or how exactly do that. So is there some tools to help me like understand what the size is gonna be? Like does Nix package just tell me what the size of this package is gonna be, if there's some options, things like that?
Not natively, no. But there is a way to ask, you had a microphone, I'm used to repeating the questions, sorry. Natively, no, at least not that I believe. Tom just walked in, so maybe Tom knows. Is there a way to ask Nix the size, like, of a resulting thing beforehand?
I'm not understanding the question. Well, the build could obviously change it in lots of different ways. So usually to find out the resulting size, you have to have already built it. But you can kind of have a lot of the components already built before you compose it into the final container. And so then you can do the math for that if the components are built, even before the final thing is built. That's the best you can do, just because compilation options can easily change the size or whatever. Yeah.
It'd be a bash script, I believe. You'd have to write it yourself.
Well, you could build all the subcomponents and then just have those be added up without building an image. Yes. The individual components, all those and their closures is all defined and captured statically. We could follow up.
Cool.
More questions?
Hi. Yeah, I didn't quite understand the popularity contest piece. Could you explain that?
You mean this, right? Nope, this one. Yeah, so the popularity contests, I'm quite vague on the details as well, but the way that I understand it, it basically gives the most popular packages. For example, libc is quite a common dependency of a whole bunch of different programs. It tries to get that up in the layer in the layers. So it tries to have that as one of the first layers that there is. Or for example, OpenSSL would also be at the top more often than not. So you need to contest to try at least and get as much caching and cache hits as possible, so that the different containers that you build with Nix, right, the layer order of them should be quite similar more often than not. If you're, for example, let's say an NPM shop, right, you write JavaScript for a living, NPM, or Node.js rather, is going to be one of your dependencies, right? So Node.js should be one of the first layers for all the different containers that you build, right? If you don't have the popularity contest, you're not guaranteed that it flips to the top.
To extend on what he was saying, you also have to take into account, it wasn't mentioned explicitly, I think, that OCI images can only have 128 layer limit. Mm-hmm. So if you had a thing that had more than 128 items of things that are coming from the Nix store, you're going to need to start compressing some of them together into layers, and you wouldn't want that to be like GCC or like libgc or glibc, things like that. I had another point and I forgot it.
Yeah, but it makes sense. So if the default setting on the layered image function from Docker tools, that's set at 100. So it generates 100 layers rather, and every single layer contains one piece of software. And then the very last image, if there's more than 100 images that it would have needed, it would have compressed them all into the final image. That's the default behavior. Whilst over here you can say, hey, no, all of the Python dependencies make one layer out of that. Just gives you a bit more flexibility in the whole process of building the layers. Does that answer your question? Okay. Cool.
Another question?
I have a question. When did I lose the audience? Was it clear a little bit? Yeah, cool. One of the reasons I want to give this talk is there was a question earlier about where do I find more information, or something that I get out of it. It's like there's not a lot of examples for this type of stuff, right? There's ample examples for Docker files and Docker. There's not that many for Nix and Docker tools and build layered image. I hope that this will be an example, and I hope many more will spawn from this. So that's, you can always help with that. Yes? Oh.
I got here late because another talk didn't go off. Did Did you show a URL for the slides?
For the slides, it's on the Scale website. So if you go to Scale, and then I'll go through this way, bloop, there we go. It should be right there.
Okay, any more questions?
Yes, one right there.
Hi, thank you. So question, the whole process is really good to someone who understands it, right? So if you have a developer that's pretty competent, comfortable with the process, tinkering, no problems. But if you have a group of developers that just want to come to work, build a bunch of containers, and then go back home, they don't have a big appetite to learn something new.
Could you hold the mic a bit
Oh,
closer?
they don't
It's
have,
difficult to stand, sorry.
if you have a group of developers that are not very interested in learning a new skill, does Flocks, for example, simplify the workflow? What would the workflow improvement be to accomplish
So
this?
Flux in this scenario simplifies the experience of it, so to speak, right? It simplifies, we're biased in that sense. We set up a very biased way of calling these functions. Yes, we make it simpler to get going at the expense of larger images. We're looking into ways where we can make it smaller. Is it even maybe necessary to make them smaller is another question that we're asking ourselves. On average, I've seen them, again, they range from 200 to, I've seen them be like 8 gigabytes in size. Depends as well what you're doing. It makes it easier because you're not exposed to the Nix expression language for Flux. You have an imperative interface where you do Flux install certain tools, and there's a command Flux containerize that outputs the container. Does that answer your question? Okay, thank you.
I have one real quick. So automating the choices that you made would require actually doing some exploration or speculative execution of the actual code that was going to be used, right? Because like, for example, say that there was another version of the cowsay package that did not wrap bash, right? You don't know that you can, like an automated installation program doesn't know, or a container builder doesn't know that you're not going to depend on the access to bash ahead of time, right? Unless it actually has, unless it actually executes the payload of the container.
Mm-hmm.
Is that something anybody's working on?
Could you repeat the question one more time?
So like
There's
I was
8
thinking
pieces
about,
list.
how you would automate this, right? Like how you would automate the choices between different versions of packages, et cetera,
Yeah.
in order to say get the container smaller or fulfill some other goal. And I was realizing one of the problems is that, the way that you did it is that they're human choices, right? You know that all you're going to be doing is calling cowsay from outside the container, and therefore it doesn't actually need bash. So if there's a version of the cowsay container that does not have the wrap command and thus is not embedding bash, you can use that and shrink the container. But the question is how an automated container builder could know to make that choice.
I'm not sure. The way that I figured this out is, again, gut feeling. It was, bash is not supposed to be in there if I'm using muscle, and if I'm using BusyBox, I'm not expecting bash to be in there. Tom then showed me a command that explained why bash ended up in there, so that's fairly nice. But I don't think an automated tool can know if it should be in there or not, if that was your question. It depends on how things are built, right? If you go look at how cowsay is built in the upstream Alpine package, it's going to be very different than how we build it, and how Ubuntu builds it, and how Debian builds it. It depends, I think, but I do not believe there could be an automated tool that would be like, hey, there's a dependency in there that shouldn't be in there. There is this thing in the Nix ecosystem called Hydra. If I could type. There we go. And this is our CI system, and one of the things that it has, if it loads eventually, one of the things that it has is a pretty graph that shows you the size of the binary over time. So one thing that you could do is set up an alert like, hey, if the binary size all of a sudden goes up by 300%, something has gone wrong. That could be a form of automation, but just like knowing it, I don't think so. Okay?
I was just going to follow up on the answer. There's also a thing in Nix packages where you can say, if you know that you don't want bash, for example, or glibc, there's a feature to say, require that this package build doesn't have a reference to, say, a specific package. So you can say disallowed requisites is like bash. And so if you know from up front that you don't want bash, you can have the system check at build time that bash is not a runtime dependency, and then it'll error out. But that doesn't solve it got 300% bigger, I don't know why. You still need someone to figure out why that happened. But if you know up front that I don't want glibc or I don't want LLVM or whatever in the final thing, you can statically say, check that during the build time. So does that, yeah.
Thought I saw another hand back here. Yes.
Oh, can I ask a question? Cool. I'm wondering what sort of additional optimization passes could you foresee Docker tools being capable of doing?
For Docker tools specifically, I'm going to be honest, I'm just a user, so I have no idea what other directions it could go into. One optimization is not really a Nix packages thing, but if Docker or other container tools could gain native understanding like Nix Snapshotter provides about the Nix store, that could be a form of optimization. Another thing that is constantly happening inside of Nix packages is just general optimizations of the standard environment that will then result in smaller binaries. There are certain flags that you can enable inside of Nix packages that will use like host-specific optimizations, but that's not reproducible, so that's disabled by default, but that could potentially reduce the size as well. That would be about as far as my mind goes. Does that answer your question? Okay.
Okay, we have time for one more question if somebody has one more question. If not,
Over there.
there we go.
Do you know if Docker tools currently support the button that's common in Docker files when you have a build image and you do not want because if I imagine I don't want to maybe publish Nix package in the public repository just for my build, for my binary being built.
Yeah, it does, and that would be this part over here, from image. So you can tell the build layered image like, hey, use this base image and go from there. There's also a way to chain these together, so you can do a weird multi-stage build in a Nix native way, but this can reference an image that's coming from Docker Hub or some other registry. It's not a directing, so you don't give the image name over there. There's a... Okay, sorry.
I was talking about the build image not as a base image for what I'm building, but I want to build my binary. I don't want to publish it to Nix. I just want to use it in the thing I'm building. I might pull some dependencies for it and so on, but I'm not going out of published things if I'm building my thing.
I don't think I quite understand the question then.
It doesn't by default go to Nix packages.
Oh, yeah, it doesn't publish by default. You can set up Nix to pull from private registries, yes. I do not hear you, I'm sorry. Yeah, you're not always publishing to the cache. Like everything that I did in the demo stayed local on my machine. Yeah.
Okay. Okay.
Okay, yeah. That makes more sense.
The question was more like, can you take the calc modified to remove the bash, and then use that calc without having to publish the new calc?
Yeah, that's all on my system. Even the building of that package happened on my system.
Yeah. Yeah. Okay.
I did not hear
I
the
think-
last thing you said.
Okay. And then we can they're continuing that discussion, and we are actually out of time.
Sure.
So thank you very much for
Yes,
an
thank you.
excellent talk.